My name is Morgan Willis, and I'm a principal cloud technologist here with AWS Training and Certification. And I'm joined by Rafael Lopes, and we are coming live from the Reinforce conference in Boston from the AWS On Air booth. So, like I said, my name is Morgan Willis, and I work in curriculum, creating online digital training for you to learn more about AWS. So I'm joined here by my host, Rafael Lopes.
Hello, how are you doing, Morgan?
I'm good.
My name is Rafael Lopes. I'm also a principal cloud technologist. I work in the same team as Morgan. We do curriculum creation for online digital training platforms, like Coursera, Skill Builder, edX, Trailhead, and so on and so forth.
Yeah.
So we are on the internet teaching you how to learn more about AWS.
And actually, it's funny, Raf and I have been working together for a number of years, and any of you that have joined our Cloud Quest show or maybe the Power Hours in the past, or we've done courses together, maybe you've seen us on Coursera or edX. It's funny because we actually haven't seen each other in person since 2018. So this is kind of a trip for us to be able to be here together live and do the final episode of the Cloud Quest show from Reinforce. It's super exciting, so thank you all for joining us. And that being said, Raf, why don't you tell us a little bit about why we're here today?
All right, so this is part of a Twitch series that we've been doing. You may have been familiar with that. It is the AWS Cloud Quest Cloud Practitioner. So we are playing the game, the Cloud Quest game, as you can see in our shirt, and we are teaching you things, AWS stuff, while playing the game. Today is Reinforce Day here in the Boston Conference Center, and coincidentally, or not, because we had planned that before, we are going to play the game node, the game assessment that talks about security, right? So today is the game. We're going to play the core security concepts. There is a web page that our moderators may be posting in the chat right now with our schedule, with the schedule of our show. Today we are in the Reinforce in Boston because coincidentally our time slot coincided with this show. But we've been doing, this is the 6th episode of the series. Let me share my screen and show you where we are. We are actually right here in the core security concepts. But because it is Reinforce, we are going to dive a little deeper on IAM.
Yeah.
So we are going to extend the scope of the regular Cloud Practitioner level we do in our shows of what we have been doing in our past episodes. Because this is a security conference, we are going to play the game node, teach you the basics of IAM while playing the game node, but we are going to dive deeper. In the first episode of our show, we talked about cloud computing essentials, then we talked about compute and infrastructure, compute solutions. In the episode 4 with our friend Aaron, we did a QA recap using a drone challenge feature that the game has. We are also going to, we may explore drones, time permitting, today. In the last episode, we talked about databases, especially Amazon RDS, multi-AZ, how to get a resilient database, difference between backup and replication, and things like that. And today, we are talking about core security concepts by using Cloud Quest.
Yeah, so just so you all know, this is supposed to be an interactive session. We are live, so if you're joining us from LinkedIn or Twitch, I here have the chat open on my screen. So the way that this is going to go down is Raf is going to be playing the game, and you're going to be seeing his screen. But on my screen, I'm monitoring the chat. We have moderators in the chat, so if you want to say hello, moderators, please say hello. And please type your questions on the Twitch chat or the LinkedIn chat, and I will be bringing those questions to the screen here so that way we can answer them live for you. So if you have any questions about the Cloud Quest game or maybe anything that AWS Training and Certification has to offer or about the topics we'll be talking about today, which will mostly be IAM, then please type those in the chat and we will try to make sure we get your questions answered for you.
All right. This web page that moderators are posting in the chat has links to watch on demand if you want to watch previous sessions of ours on demand. So let the games begin.
Yeah, let's dive in.
All right. I already have my Cloud Quest account opened. If you remember in our past episode, I got that doctor outfit. We are looking like a friend of ours, Dr. Blaine. If Dr. Blaine is watching that from training and certification as well, hey Blaine, I put this outfit for you. And there is this girl here waving for us with her pink hair. And this is how Cloud Quest works, right? You have assessments, you have a hands-on lab account, you can do the assessments, and there is a dialogue between you, which is the solutions architect, and the customer. This dialogue in Cloud Quest is pretty instrumental because it mimics a real AWS solutions architect and a customer in real life, in the sense of you ask things for the customer and then you start thinking about infrastructure requirements.
Right.
You start thinking about which components, which services you are going to use for that according to what the customer wants.
Right. So in this case, we have the city, right? And we are helping the city build different things with AWS solutions.
Exactly. And in this specific game node, it is about a city stock exchange. I love the storytelling in Cloud Quest. It gives you funny stories per assessment. It's super cool.
Yeah, it's super engaging. And just as a quick side note as well, this training, it has these sorts of scenarios that help you think through the AWS solutions, but it also has training embedded in it. So this is a really, really great way to get started with AWS in an engaging way. So if you like games, definitely check this out.
Totally. So that lady with pink hair, I like her hair. Hello and welcome to the City Stock Exchange. Thank you for answering our call. No problem, how can I help you? And I love to have the doctor outfits and saying, no problem, how can I help you? So we recently decided to create a support engineering team. However, as this team grows, we want to be able to manage users efficiently. We want all support engineers to have the same set of permissions. Can AWS help with this? And then you start already thinking about the need of that customer, which in this case, it is a simple account. You're going to create an IAM group for support engineers. And then part of the solutions architecture job is also educating the customer and letting the customer know which AWS service does what, right?
Right.
Not only getting the requirements, doing everything and presenting a POC, but also explaining, because many customers may not still be familiar with the cloud.
Yeah, and at the end of the day, they're going to have to support whatever solutions you build. So you want to make sure that your customer understands what you're building.
Exactly. So, okay. So with policies, do I have to learn every type of permission for AWS services? I just want my support staff to have read-only access. So with IAM, as we are going to see when we dive deep in these sessions, you can have IAM policies, and you can apply permissions on multiple locations in AWS. You can apply on the user side, you can apply on the resource side, right? So we're going to talk about user-based policies, resource-based policies. So. But for now, in this very simple lab as part of the Cloud Quest Cloud Practitioner, we're going to attach a managed EC2 read-only access policy to our IAM group, all right? So the dialogue.
Just to kind of clear that up, right? We are going to be showing a pretty simple use case here.
Yeah.
But this is the foundation for learning the more complex use cases. So this is for the Cloud Practitioner level, and then we'll be able to build on top of this as we go throughout the session today.
Yeah, and keep the questions on the chat coming.
Yep, we already have a couple, so I'm going to go ahead and get those going as well.
Go ahead.
All right, so we actually have a question that says, how can we search policies from IAM? Can we show a demo for that? So we will show a demo showing you how to locate policies during this node, actually. So stay tuned, and we will get you an answer for that one.
Yes. So let's continue here, and wow, seems that there are lots of options, and that's important to consider, right? The security and credentialing and infrastructure management in terms of security in AWS can get pretty complex if you don't do the right thing from scratch. If you don't work with IAM roles, if you don't correctly do like federation with identity providers and things like that, if all you do is managing users and groups, you may get in trouble pretty soon. So it's important to say that, but let's also just tell our audience the difference between console access and API keys access. So I'm having this dialogue, and I will accept this quest and start with a hands-on lab exercise by going to the Solution Center in Cloud Quest. And the Solution Center is the location where you will be given videos, instructional videos, where you can learn about that specific topic. And we have multiple assessments as part of each role in Cloud Quest. And in addition to the knowledge you can learn from the video and the animations, you will have step-by-step instructions, and an AWS account you can apply. You can do these instructions to learn by doing.
Right, and so this is all it's all in one place. Like you have the game, which includes the videos for learning, but then also you can launch the labs in a hosted environment where you can complete them in kind of like a sandbox. So this is a really great place to get started. So that's what you're going to see us doing now, is going through this first assignment event, and we're going to be explaining the concepts behind IAM and behind this, but all of the concepts that we're covering are also embedded in learning objects in the game. So you can always go back and take those at any point.
Yeah, I can see my friend Adam is saying hi on the chat. Hi Adam, nice to see you. So this is the architecture that we are going to implement pretty quickly. We are going to create one user. We are going to create one group. We are going to associate that user with the group. And we are going to put a policy in the group. And while we do all that, we go double-clicking and explaining in more depth what we are doing, right? So we are going to create a user that initially only has Amazon EC2 read-only access. So read-only access, right? So we are going to log as this user and go to EC2 and observe that we can describe the instances. We can see what the instances, everything, because it's read-only. But if we try to create a new instance, we will see that the API call will fail because IAM will have something called implicit deny that says that if something is not explicitly allowed, then it's denied. There is a flow chart that looks like this, which we're going to talk about more in depth later. So let's continue with our lab here, and then let's go to practice. So we are going to create IAM groups, we are going to attach policies, and we are going to explain you what we are doing. I'm going to hit the option Start Lab in Cloud Quest, which will give me an AWS account to play with. And while the account is starting, we can review our lab steps. So step 1, it's the concept of the lab, and then there are screenshots in Cloud Quest defining you where you can click and where you can learn the things.
So this really guides you through the whole process if you are taking the game yourself. So it really takes you step by step through the whole thing. Like Rafael said before, we are going to just kind of go through and explain a little deeper as we go along than what the instructions give. So that way you get some of that learning and the lab at the same time.
Yes. So here are the labs, the AWS Identity and Access Management. Then we are going to create a group. First, we are going to create a group. Then we are going to type the group name, right? Then we are going to choose a policy from one of the AWS managed policies. So when you go to the AWS IAM console and you see the policies, if you see policies that has a little cube on the interface close to them, it means it is an AWS managed policy.
So what does that mean? Like, we have an AWS managed policy. So let's kind of back up a little bit, right? We have IAM, and IAM is how you can control access within your AWS account. So IAM controls access to AWS API calls. And you have entities or principals that you can apply permissions to, and policies are going to allow you to define what those permissions are. So what Raf is talking about is this idea of a managed policy versus an unmanaged policy. So can you explain to me what the difference is between those two things?
Yes, sure. So when you see an AWS managed policy that says, for example, administrator access, right? It is a policy that is pretty much permissive. Someone that has that policy can create resources in your account, describe resources in your account, modify resources in your account. Because that is a managed policy, if AWS releases a new service, right, then that policy will be updated with that new service as well.
Automatically.
Yeah.
Right, so you don't have to go in and do anything.
Exactly, because it's a managed policy that says administrator access, right? Or, for example, Amazon EC2 read-only access. If AWS announces a new feature on EC2, right, let's say whatever new feature, then that policy will be updated and it will allow users to read.
Right, so a new feature would imply that we have a new API call. And so with these IAM policies, Rafa just said everything is implicitly denied, meaning that all API calls by default are going to be blocked. So you have to add every API call to your policy. So if a new feature gets released, that's going to have new APIs. With managed policies, those will be updated automatically. Whereas if you have a customer managed policy, which is a policy that you create, you have more control over which API calls get included when, but that also means that you have to manage it yourself. So there's this trade-off there between convenience and control.
Convenience and control, exactly. And when you want to start doing more refined secure guardrails in your account, you may need to write a policy that uses some explicit denies. I have an example here of an encryption key from KMS, a customer master key, a CMK from KMS, that has an explicit deny on everyone in the account except for one role. So I'm going to show you that that policy.
All right, we'll take a look at that in a bit.
Yeah, so here are the instructions. They are pretty simple. I'm going to create a user, a group. I'm going to attach a policy in the group, and I am going to add the user to the group, log as the user, test the policy, and then go back to Cloud Quest and validate. So
Perfect.
here are the steps, step 5, step 6, step 7. I already memorized all these steps, so let me just go to the console and do the action. So first thing I'm going to do is create a group called support engineers, right? So support engineers. Group names should be as most generic as possible, right? Because a group will have a collection of users. You can understand a group as a feature in IAM that will have a collection of users, so you don't need to apply policies individual per user. So if multiple users, they share the same need of accessing AWS, you can create a group and put the policy in the group.
Right, so that way, like if I'm a QA engineer, I have a certain set of permissions, and then if I change job roles to go be a software engineer on a different team, they can move me from one group to another without having to change my individual policies. Instead, I will inherit whatever policies are attached to the group, as well as any individual policies that I may have attached to my user.
Exactly. Groups are a collection of users. That's right. Now, I can have the option of adding users to the group when I create the group, but because I don't have any users so far, I'll just proceed creating the group, and here are the policies. You can notice that I can create a custom policy at any time, or I can choose from a list of policies. And all these policies from this list, they are AWS managed.
Yeah, and also for the person that had the question in the chat earlier about how can you search for policies, this is how you would do that. So Raf's showing you right now.
Yeah, so if I type Amazon EC2, there is Amazon EC2 full access, Amazon EC2 role for SSM. SSM is Systems Manager. It is an AWS service that allows you to do some management tests in your instances, in your architecture. And there is one feature in SSM that we talked in episode 2, which is Sessions Manager.
Right.
So you can use that policy to allow an instance to use SSM. For our exercise here, we are looking for Amazon EC2 read-only access, which is this one. If you extend this policy, AWS managed, if you click on this policy, actually, you can see how the policy JSON document looks like, I think. Yeah, I don't, because the Cloud Quest account is locked.
Right.
I have my other account here with full access that I can show you. For now, let's just choose this policy and create the group. So Amazon EC2 read-only access, now the group is created, and I am able to create this group and change IAM things because the account that Cloud Quest gave me, I am assuming a role in that account. We're going to talk about roles soon, but the role I assumed gives me permission to do that.
Right, but it only gives you a certain, this is actually a great example of what we mean by the principle of least privilege.
Exactly.
So within AWS, we want you to follow a principle of least privilege where you give people only the access that they need and nothing more. So like for this lab, for example, we have a certain set of steps, certain function that we're trying to perform, and the role that we've assumed, which we'll talk about roles, have exactly the API calls that we need and nothing more. So whenever Raf goes to try to explore around the console, you're going to see a lot of errors, and that is a good thing for security. That means that we followed the principle of least privilege and that we've locked down this count accordingly.
Yeah. So once we have the user group, because the user I'm using that account, the role I am assuming in that account gives me permission to do that, I have the group support engineers created. Right, so I am going to create a new user, and I am going to create a user called, let's choose support engineer 1. Ideally, that would have my name, right? We want users to be as less generic as possible because we want to associate users with entities. And here we can allow this user to have an access key, which will allow programmatic access to do automated things in AWS. And or we can allow that user to have a password that will have access to the AWS Management Console.
Right, so
for now, yeah, go ahead.
We have this, now let's talk about the difference between an access key and a password. So in AWS, whenever you're interacting with resources, everything is an API call. So whether you're using the AWS console or the command line or the software development kit, all of them are making API calls on the back end. If I wanted to use, let's say, the command line on my local machine here, or if I wanted to have a program, like a Python program that calls out to AWS, we need a way to be able to authenticate our command line or the program with AWS. Now, you aren't going to assign a user and password to your command line or to your program. Instead, what you're going to use is you're going to use these keys. So we have the access key, the AWS Access Key ID and then the secret access key, and these two things together is what allows you to sign these API calls and make them in an authenticated manner to AWS without needing to have something like a static password. Now, you may have for your user within AWS, you may have an associated access key and secret access key, and then you also might have a password. So the password is what you're going to use to log into the console. The keys are what you're going to use to make calls to AWS using things like the command line or the SDK.
Right. So once I choose a custom password to that user, I can also allow that user to change the password at the next sign-in if you're creating that user to someone else. And and in the next step, I can choose what will be the permissions these users have. So I basically have three options. I can attach existing policies directly to this user to grant the user the permission of doing or not doing something in the AWS account. I can copy permissions from another user, or I can add that user to the group, which is the most convenient way, because from the point you have a collection of users, you can just add these users in the group, and all these users, they inherit the same policy. And I am going to add this user in the group that I just created called support engineers. Right. So review and create. Now I have a user created, and these users, they sign in the AWS account as a different user, right? With a different URL. That URL usually has the account ID. So, or an alias, if you decide adding an alias to your AWS account. I am going to copy that for now and open that in a separate browser tab. So let me close.
All right, so just while we're doing this really quick, we do have a question from the chat that's kind of related to our compute episode and this one. And we have a question from King Wales that says, can I use the same key pair I saved every time I want to connect to my Linux instance via SSH? And the answer to this one is yes, you can. That being said, you should probably rotate those key pairs regularly and make sure that you're keeping them somewhere safe. So if, for example, let's say you have your key pair saved locally on your laptop and somebody was able to gain access to your laptop for some reason, they could then use that key pair to SSH into that instance. So you want to make sure that you're keeping them somewhere safe, maybe in a protected storage, and then you also want to make sure that you're rotating them on a regular basis. So that way you don't have like the same key pair is used for all instances and it's been the same key pair for 5 years, right? That leaves an open door there.
Yeah.
So you want to make sure that you're rotating those things on a regular basis. And actually the same idea goes for the access key and secret access key that we associate with our users.
Yeah. So it's important to differ that the EC2 key pairs are different than the IAM credentials.
Yes.
So when you are talking about EC2 key pairs, you have a private key and a public key. Usually, if you ask AWS to create the key pair for you, AWS will create the key pair, will give you the private key, and will keep the public key, right? If you don't trust that AWS didn't keep a copy of your private key, you can generate the key pair in your laptop and only import the public key, right? So this is cryptography. There is no way to reach, at least as human being knows, in the time frame where a human being lives, there is no way to revert and reach a private key from a public key. So.
Right. You can't generate one from the other.
Exactly. Yeah. You can generate the public key from the private, I believe, but not the opposite.
Not the other way around.
You cannot generate the private from the public. So AWS keeps the public and you keep the private key in your laptop, right? So whenever you create a new instance, when you ask AWS to put the key pair in the instance for you, it's actually not putting the key pair, it's just adding the public key. And you that have the corresponding private key will be able to log in. But if you don't rotate that, it will always be the same private key and public key. There is an AWS feature, EC2 Instance Connect, that it generates a key pair, public and private, and it injects the public key for 60 seconds in an EC2 instance and gives you the private key for you to connect within that 60 seconds, right?
Right.
And you can initiate that call from an authorized IAM user that can interact with EC2 Instance Connect.
Right, so it's kind of like we're like chaining multiple different types of authentication here. Like I said before, IAM is for AWS API calls. So like I want to create an RDS instance. I want to list all EC2 instances. I want to list all S3 buckets, those sorts of things. Whereas connecting SSH to an instance, right, we are actually going to be talking to the operating system of that instance there. So you have the AWS networking rules in place, like your security groups and your network ACLs and things like that. But these are two different concepts, though they do kind of work together in the way for features like AWS Instance Connect, as Raf just described. So it's good to remember that these are different things, and IAM controls AWS API calls specifically.
Yeah, yeah. So I copied that URL. I am going to open a new window and paste that URL. And now you can see that it already populates with the account ID because I have that as part of the URL. So I am going to put support engineer 1 here. and then the password I chose for that user. And then now I am logged in the AWS account as support engineer 1, as you can see on the top right corner. And because that user has EC2 read-only access permission, if I click in EC2, that user can describe the instances. When you click and navigate through the console, you are under the hood doing IAM API calls. And this, when I click here, I do an IAM API call called describe instance that will give me all the information about that instance. Same with instance types, describe instance types. So you can see I can read only through this console with no errors. So I can describe the AMIs, right? I don't have any images in this region. I can describe the volumes, which probably I have one volume because I have one instance running. But if at any time I go on that instance and I try to stop that instance or write something in that instance in terms of configuration, right? Change the instance type, change networking, change security groups, change something. So if I go here, instance state, stop instance. The stop instance is an API call that is not part of the read and describe.
Yeah, it's
right?
not in that policy.
Exactly. So I have a failure because that user cannot do that, right? So
that's good. That's what we want to see.
yeah, exactly. So terminate the instances fail because the policy is read only, right? So let me save this window here on the side for a bit and go back to Cloud Quest. And all I did was just following the steps here. I didn't go step by step because I didn't want to change windows all the time. But here you have the support engineer 1 with the password and EC2, and go check that you are in Virginia and try to terminate the instance, and then the instance termination will fail, which is the very same error message that we saw, right? So congratulations, you complete the practice session. Now let's go to the do-it-yourself section to complete the solution. So let me go to do-it-yourself. And they want me to go to the account and grant the support engineers group read-only access to RDS as well. And there is a managed policy that does that. It is the RDS read-only access. So let me go to my account as the administrator, as the user that can change policies, and go in the group and add another AWS managed policy to that group. So let me choose support engineers, permissions, add permissions, attach policies. And the policy name it wants is RDS read-only access. We are going to dive deeper in these policies as soon as we complete and get our prize. So RDS read-only access, add permissions. So now we are adding permissions to that group. Now that group has ability of doing EC2 read-only access and RDS read-only access, right? So the Quest validation in the game, I just need to put the IAM user group name. So the IAM user group name, as we can see here, is support engineers. So let me copy this. So remembering that this is Cloud Practitioner level, right? So in terms of security, all you need to know in the exam for doing the Cloud Practitioner, for example, is users and groups, right?
I think
and some managed
need
policies.
to know what roles are.
And roles, yeah.
So you need to know users, groups, roles, and policies, the differences between them for the Cloud Practitioner level. Now, question, and this kind of relates to IAM as well, is we have a question from Ghost Lynn. Could you make MFA mandatory for IAM users in a specific group? And so for this one, I believe the answer is yes. So you can force people to use multi-factor authentication whenever they log in to the console, and you can also require that multi-factor authentication has been performed whenever certain API calls are made. So meaning that they would have had to use MFA to log in, and then there's something attached to their session that says like, yes, they used MFA to log in. And then you can, in the policy, you can check to see if that attribute exists, and that if it does, they will be allowed to make that call. So you can enable MFA for specific users and groups, and that will force them to use a multi-factor authentication token to log into the console, which is a best practice as well, especially if you're using users and passwords. Because if I have a user, it has a static password. So for some reason, let's say you wrote down your password on your desk because you forget it a lot, and then I walked by your desk and I grabbed it, and then I logged in. If there's no MFA, then I can just log right into the account and do whatever you can do, which is not great, right? So we want to make sure that we're using multi-factor authentication whenever is possible, and especially on static users and then really especially on the root user.
Yeah, really especially on the root user. And in addition to that, you can have identity providers federation, and you can rely on passwordless authentication in these external identity providers. So you can do a federation from an external identity provider such as Okta, Microsoft Active Directory, with Active Directory domain controller sign in with your users and groups already set up, and you can have solutions that will give you a single sign-on URL to the AWS Management Console, assuming a role that you are authorized to assume, right? So you can create that solution on your own by using the AWS API calls, but there are many solutions in the market that you can leverage that already does that for you. Right.
And we have a question in the chat here from Ken Sherman, 902, and they say, do you think AWS is implementing or will usher in implementing more passwordless solutions in the near future? And I think that's exactly what we're talking about, right? It's like passwords are static, and you need to make sure that you update them. They are vulnerable in some ways that if somebody guesses the password, they can get into your account. So instead what we can do, well, there's another problem as well, which is just managing so many passwords, right? So if you have, let's say, 10,000 users and you're a corporation, and they all have corporate logins, like whatever you log into your laptop with, you have a username and password, and then you also want to grant all those people access to two AWS accounts, do you need to then recreate all of those users and passwords in the account? That's a little bit cumbersome, right? And then you'd have to keep them in sync, and it's kind of a whole thing. So instead, we're going to be talking about what Raf was just saying, which is federating users so that you can use your corporate login, and that identity provider has a trust relationship with AWS. And you can then log in with your corporate identity provider, and then you can authenticate with AWS through that trusted source. And that will allow you to have kind of like a passwordless way to get into AWS, because the password is managed by your corporate identity provider like Active Directory or Okta, things like that.
Right. So let's collect the resource, the reward in Cloud Quest.
Oh yeah, this is the fun part.
This is the fun part. This is where I can enhance my city. So thanks for building this solution. Please choose a reward. So I would like help from the chat. You can type 1, 2, or 3, and we will see the majority of the messages here. Which solution do you think I should pick? I think on the last episode we picked the castle, right? So
yeah.
Our city is becoming pretty much
medieval.
Yeah.
Yeah.
So.
Yeah, I love how it gives you the different options for your city, and then it's just like a nice little quick win at the end whenever you complete a node, and you can build out your city. So your city becomes more complex and more interesting as the game goes on, which kind of entices you to keep learning. And so we want to remind you that this game is all about learning. So it's fun and it's engaging, but you also are going to learn a lot. So whenever you get through a node, you get to choose your reward. So let's see what we have going on in the chat here.
Let's see. The Goblin Camp. Is Goblin Camp the second one? Middle-aged city?
Yeah, it does look like that.
1, 2, which one?
Yeah, it looks kind of like caveman style camps here in the second one there.
The second one, yeah. We are also live streaming to LinkedIn and Twitter live spaces.
Yeah,
as well,
on LinkedIn. So if anybody's watching from LinkedIn, please feel free to type in the chat what we want to redeem as a reward for the city as we build out our city.
Yeah, I think number 2 is getting the majority here.
Yep, I'm seeing number 2 as
I
well.
hit the button. I hit the
It's
button.
2. We're going with 2.
So fireworks, and look at that. Like, that's...
Wow. That is super interesting.
That is cool, right? So after you complete a node in the game, an assessment in the game, you unlock reputation points, you unlock gems, which you can use to customize your character, buy vehicles, and unlock city themes, right? And you also have 4 more customizations you can do in the city. So let me go ahead and you also level up. My player is on the level 10, and these icons here in the city represented by a hammer and a wall. You can use the gems you got. I have 220 gems to unlock something in that city. So I can buy this lighthouse, for example, and put it here.
Very
and then
cool.
It consumed my gems.
I like how like the mismatch of things that we have going
like
on in the city at this point.
This is the Museum of National History, actually.
Oh, that is beautiful. I love that. It's a very highbrow city that we're building here.
And I can change as well. So I can go here and I can put a commercial building if I want it to look like Manhattan, right? So, and I can also go to the player island and unlock city customizations and outfits and things like that. But if I click here in the customize avatar and click on the option on the clothing options, I can buy different clothings. So let
Go
me
to the boutique. Is that where you buy things?
to the boutique. Yeah, exactly.
Awesome.
So let me save with this one. I just lost my PhD degree. I'm not a doctor anymore.
Yeah, that's pretty sad. It
Now
went
I
away
look-
just like that, quickly.
Yeah, exactly.
Easy come, easy go.
Easy come, easy go, exactly. So there are also drones flying in the city, right, as you can see here. And this is a drone that is a challenge. The drones that has an orange eye, they are challenge drones. And challenge drones, you answer the questions that the drone presents to you by dragging and drop service cards.
Okay.
So it shows you an architecture, and you have to drag and drop cards to complete the architectures. Let's get a regular drone question here, just to show our audience how the drone looks like before diving a little deeper into IAM. So
Yeah, we still have more to come on IAM, but let's explore the city some more while we still got it. This is our last episode of Cloud Quest, so we want to make sure that you get a whole view of the city here.
yeah, so let me get my drone capture device. Look at that. And let me hit this guy here. All right, route and go. So it routes to the drone, and there is a countdown timer. If I don't go to the drone within that time frame, the drone goes back.
So you
It
gotta be
flies
quick.
back, it goes away. Yeah, so it's going automatically for me, and there it is. So when I arrive at the drone, I need to do one extra shot in the drone, and then, oh, look at that. It's
perfect.
an IAM question. So in an IAM policy, which option designates the API calls to allow or deny? And that's interesting because that's the question that asks you to understand the anatomy of an IAM policy.
Right. So we can
Right.
bring up a policy and show you after we get through this question. But the structure of an IAM policy, so which option designates the API calls for allow or deny? Is it the principal? Is it the effect, the resource, or the action? So we have different sections that compose an IAM policy. And which one of these here do we think is going to be controlling which API calls you can make? Let's go ahead and take a look at the documentation, and let's talk through this one. So here we have an example of an IAM policy, and you can see we have the statement, and this is going to be including things like the effect, and your effect is either going to be allow or deny. That's the only two options, allow or deny. And then you have, and those are what we call an explicit allow or an explicit deny. And then we have the action, and the action here says DynamoDB : star. So if I'm looking at this, I'm thinking, okay, DynamoDB, the service, colon, and then that star is a wildcard that would include all DynamoDB actions or API calls. So whenever you hear API calls, we're thinking actions. So, and then underneath of that, okay, here we go. We can see some of the DynamoDB API calls on the screen now. So you can see there's a bunch of different ones, right? Like batch write item, create backup, create table, delete item, delete table. So these are all different AWS API calls that you can include in your policies. If you have a star like it is here, that's a pretty wide policy. That's pretty permissive. We're essentially saying this person is like a super admin for DynamoDB, or this entity is a super admin for DynamoDB.
Yeah.
So then under the action, we have the resource, and that's going to be what AWS resource do we have. And notice how we have this ARN here. It goes ARN, AWS, DynamoDB, US East 2, the region, the account number, and then we have the resource at the end. So we're saying the table, and then the table name is books. So what actions are we talking about? Are we allowed to do them? Are we not allowed to do them? And then we have against what, or where are we making these calls against? So this is the structure of a very basic IAM policy. These can get very complex, but knowing this here, if we go back to the question, let's take a stab at this from the chat here. If you can, from the chat, let us know, what do you think it is? Is it principal, effect, resource, or action? Knowing what an IAM policy looks like now.
Yeah. So per state, you can have multiple statements as well, right? And within each statement, you can have SID, which is a statement ID, which is a comment that you can put in that statement. So you have a complex if you have a complex policy, allowing this, denying that, being very granular on something, you can put like comments as statement IDs, right? So you could replicate that, and you could, if you want, for example, the very same policy to do both DynamoDB and something else, you could go, let me just put this to highlight JavaScript JSON.
We're going to make it a little bit bigger, too.
Yeah, and make it bigger. So if you want to have multiple statements here, you could put a comma here, and then do the very same thing under that. I think this syntax is that like, right?
I think
You can
so.
put multiple statements.
And so you can get really complex with these things, and we haven't even covered things like conditions yet. So the policies
Yeah.
can get very long, as you would likely need to do more than just one thing as an entity working in AWS. So like if I'm a developer, I might need to do a whole bunch of different things. Like maybe I need to use Cloud9, I need to be able to access S3, I need to be able to modify RDS instances. It really depends on your job role, what you need to do. But you would essentially have explicit allows for all of the different API calls that you would need to make. All right, so it
Yeah.
looks like we have in the chat, we have here people are selecting 2 for effect. So let's go ahead and see.
Let's see.
Incorrect answer. All right, let's talk about why. So if we go back, yeah, go ahead and go back.
I think there is no way to go back. The drone.
No, I mean to the policy.
On here. Okay.
Yeah, there we go. So here, if we look, the effect is allow or deny. And so it was asking us what would control what API calls you can make. And where you list those API calls is going to be in the action section. So the effect is going to be you're allowed or you're not allowed. Those are your only 2 options. Your API call, you have a lot of options. You have as many AWS API calls that exist you can put in your action here. So that is the piece that's going to control what you can do or can't do.
Yeah. So speaking about those policies, all these policies we are seeing, they are the analog to a badge, right? They are analog to this. It's something that gets attached to an IAM entity, right? So I have a badge, I have these permissions. That's why they have a resource, because this action is on IAM. They are like a badge, assigned with an IAM entity, and they point to a resource. A resource is what to do.
Right.
But we can also have the option of specifying policies in some services, right? So in the first episode of our show, we assigned a bucket policy, which is a policy that has the same format, the same anatomy.
Yeah, this should look familiar if
They should look familiar, but instead of a resource, they have something called a principal, which is an actor who is doing something. Can you tell them the difference between a policy that has a resource and a policy that has a principal? In other words, like the difference between user-based policies and resource-based policies.
Yes.
And meanwhile, I am going to leave the Cloud Quest account and open my own AWS account.
All right, perfect.
Because I have more access to
Yeah, we'll go ahead and do some
navigate.
more exploring with IAM.
Yeah.
So what we're talking about is we have identity-based policies and resource-based policies. So identity-based policies are what we just talked about. So I can create a policy, I can attach it to a user group or role, which we still haven't touched on roles yet. I promise you we will before this is over. And whenever you have that policy, it can be attached to multiple entities. So if I attach it to a group, it will then cascade down to anybody in that group. But I can also take one policy and I can attach it to 50 different users. And the policy is the same. If I go and make an update to that policy would then be updated for all 50 principals that have that attached. Now, with resource-based policies, they are one-to-one. So let's say I have 10 S3 buckets and I create a bucket policy. You would need to have a separate bucket policy for each bucket. So if I update the policy on one bucket, it does not impact other buckets. Now, these 2 things together will decide whether you can be allowed or denied to make an API call. So let's say, for example, my individual user has the permission to make a call to S3, but the S3 bucket policy is explicitly denying my user as the principal. So like Raf just said, in a identity-based policy, you have resources that you can grant principals, so like users, to have access to those resources. But whenever you're working with resources, it's the inverse. You allow principals to interact with that one specific resource. So it takes 2 of these things together, both of them, to allow you to access that resource. So we have identity-based policies and we have resource-based policies. And it's really important that you understand the difference between them. Not every single AWS resource allows you to use a resource-based policy, but some of them do. And it's a really great way to control access to that resource in like one singular place. So instead of saying, I'm going to go ahead and apply these permissions to every single user in my account, instead I can apply the permission directly to the resource, and then anybody in that account, regardless of the permissions that they have to go through that gate of that resource-based policy to whether they can or cannot access that resource.
Yeah. So that's important to have a service perspective out of that, because sometimes, especially for services like AWS KMS, which deals with encryption keys, right? You may want a specific key to be, you want to add an explicit deny in a specific key that explicitly denies anyone in the account except for one IAM entity to get access to that key, right? And that entity can be used by an application. And it's important to have that because you may have IAM users that has the administrator access, which they are allowed to do everything on the account. But something that has been explicitly denied in an IAM policy can never be allowed. So there is that organogram that talks about the order where things are evaluated in your AWS account, which is the policy evaluation logic. And you can, let me load the organogram. It's right here. I like this organogram a lot. Let me copy the image and on a separate tab for you to see it bigger. Let me get it here. Copy image address, copy image link, and open in a new tab.
So this is a great example of just how complex things can get, right? So we've talked about things very simply in simple terms, but that's just the foundation. And we're kind of building up to this flowchart, right? It's kind of a big diagram.
Exactly. The decision of allowing something starts with a deny. That's what we call the implicit deny, right? Which means that if something is not explicitly allowed in any policy you can put in AWS, it is implicitly allowed, right? So it's kind of the same mindset that security groups follow. If you don't explicitly put a rule in the security group,
it's
the
denied.
core is closed,
right?
So it kind of follows the same principle, which is the principle of least privilege. If something is not explicitly allowed, then it's implicitly denied, right? It's not happening, right? So, and then if there is an explicit deny, then
That's
deny
it.
exactly.
Right.
So let's imagine that we are talking about describe keys policy, describe KMS keys, right? This is the action, like KMS describe keys. So it evaluates all the policy. If there is a deny, then no conversation, it's denied. And I have in my account a specific key that has an explicit deny, which is basically this one, and it's even denying me to describe it.
You can't even see that it's there, right?
Exactly. So I'm logged as the user Rafael that has administrator access in this account. If I go to IAM and show you the policy, it allows star, right? Effect allow, resource star, everything.
So that's your identity-based policy, right?
Yes, that's my IAM policy that is attached to my user. But if I am like administrator access and can see everything in the account, why can't I describe and why can't I interact with this specific KMS key here, right? I cannot do KMS describe key to one specific key, which is this one here. It tells me the alias of the key. Because that key got an explicit deny on the key policy.
On the
right?
resource-based policy.
On the resource-based policy.
These two things are not working together, right? You have your admin policy is saying this person can do everything, but then this resource-based policy is saying, I want you to explicitly deny that user. So the explicit deny will always win out over an allow. So even if you have both an allow and a deny, the deny will always win over the allow.
Exactly. But you can ask me, so Raf, how did you create that key and how did you put the policy in that key? Because
if you don't have access.
If you don't have access, right? So
curious.
I could create the key and specify that policy when I create the key. From the moment I hit create, for that specific one, I lose access. It's like I create and instantly I don't have access to that resource. But I created that specific one with the root account.
I was just going to say, so the only way you could really modify this at this point would be with the root user.
Yes, exactly.
Root users cannot be constrained. So they have complete super admin privileges in your account, and even if you have all these policies or whatever, root account can do whatever they need it to do. So if you're logging in with the email address and password, that's your root account.
But then it's not recommended to use the root account.
It's
How could I make that key more secure? Especially because only a role can interact with that key, right? And as administrator, I can go on the role and put myself on the role trust relationship to go there and assume the role and be able to assume that key. Well, I could create another AWS account, create that key in that other separate account, and use what we call an SCP, a service control policy, right?
Really quickly, let's define roles before we run out of time here.
Right, yes. So on IAM, you can have user groups and roles. Those are the three IAM entities that you can have. Users, they have individual credentials, just like the one you saw on the Cloud Quest lab we did. Groups are collections of users, right? And roles are a special IAM entity that you assume. You do a special API call called assume role. When you assume that role gives you temporary credentials, which may be user a link a single sign-on link to log in the AWS Management Console, or access key credentials for programmatic
a
access.
temporary access key. So
temporary one,
whenever you
exactly.
assume the role, it gives you keys that are valid for only a certain amount of time, and then they expire. Whenever they expire, you have to re-up those keys. So this is how we authenticate things like programs. Like I said before, we don't want to give like a program. Let's say I have a Python program running on a Linux instance, and that needs to call out to S3. I will not code my access keys into that program. Instead, what I do is I associate an IAM role with that instance, and then the software development kit knows to go look for a role. And then if it is there, it will then say, OK, give me the keys. And then it gets some temporary keys. It can then use those. So there's no username password thing going on here. It's just a continual refresh of these temporary keys. And they expire on a regular basis that you can configure.
Yeah, so if you have the need of using an AWS credential within a source code, right, you don't hard code those into the code. You have the code running somewhere that can assume a role for you. If that code is running from within an EC2 instance, there is a mechanism in the EC2 instance, and the AWS SDKs, they know where to get.
Yeah, you don't have to code that yourself if you're using the SDKs.
Yeah,
it knows where to go. There's like a chain, an authorization chain that it goes through. Also, really quick, total side note here, unrelated to this episode, but I want to make sure that I answer King Whale's question. I promised I would. So he has a question: how do you know the CIDR block to use when creating a subnet, and must your subnet CIDR range be under the CIDR that you set for your VPC? So whenever you define your VPC, you have a CIDR range, and that's like a large block, and then your subnets are just a subset of that. So you have to select a range for your subnets that are a subset of the CIDR range for the VPC. And also remember that subnets are just chunks of IP addresses. So you would pick ranges that are going to be relevant to like the size of, like, let's say you have a lot of private resources but very few public resources. You would have a larger private subnet and a smaller public, and you would just have to make sure that none of your subnet ranges overlap. So yes, they have to be, subnet range is a subset of your VPC range. So there we go. Just wanted to make sure that I answered that one. We can go back to the show now.
That's good, thank you, yeah. So how could we make that specific key safer, right? We could create a secondary AWS account, put that secondary AWS account as part of what we call AWS Organizations, which is a service that helps you managing sub-accounts, child accounts. And then there is one special thing about AWS Organizations, which is the SCP, which is something that I like to call account-wide policy that overrides identity-based policies. And as you can see in the chart here, the organization's SCPs, the evaluation comes before identity-based policies, which is what we did. The identity-based policies is what we did on the lab, right? This is basically the IAM policy for the user, the support user we created.
And there's all these checks before that.
There are like two checks before that. Resource-based policies, which is the one that is the key policy, right? That is explicitly denying something, right? And then we could put that key as part of a secondary account in AWS Organizations and put an SCP also denying access to that key for anyone else other than a specific role that is assumed, that is authorized to assume that key.
Right, so this is like, if you have, whenever you're working with AWS, you likely don't have one account, you have many AWS accounts, and you can organize those into a hierarchy. So let's say you have your accounting organization and they have their own account, and then you have your developer account. These two roles have totally different permission sets, right? Like the developers are not going to be doing the same things as the accountants are. So, but we still want to have them managed under the same AWS account tree. So you can apply these account-wide policies called service control policies. So you can say anybody under the account wing, so any child account under this node here, is going to be only allowed to have access to accounting like services, and the developer node over here, any child accounts under there, same thing. So we can apply these service control policies at different levels in the hierarchy. You can apply them up at the top, at the main node. So you can say no accounts in our company are allowed to use X service. But then you can also do it where you do it just like a lower node as well. So it really depends on what you're trying to do, but it's just another way to control access. And one of the reasons why we have this sort of thing is so that way you don't have to, let's say you have 100 AWS accounts. You don't want to have to go into every single account and set the policies, right? It's much easier to set it at a higher level. So that's where these service control policies with AWS organizations come in.
And there is where you can find it inside AWS organizations. So if you want a policy to be validated to the whole account, like in the account boundary, you can create an SCP. But for that, you need to create an account. You want to isolate that in a separate account, put the key there, put an explicit deny on the key, allowing only one specific role to use that key. And in addition to that, you can use an SCP to reinforce the boundaries, the guardrails there.
Right, so we have multiple layers of denying here, right? Like that's the main thing that we want to try to get across with IAM is that really the default is deny for everything. And you want to make sure that you're only allowing very specific things. Like what Raf's talking about is like we have a key and then we're only allowing one role. Other accounts, other entities can assume that role, but they can only get to the key if they've assumed that role. And that includes things like programs. So if you have a program that needs to access that key, it would have to assume that role, get the temporary credentials, and then it would be able to access the key.
Yeah, so let me point to our viewers where they can find more information about that, because I know it is overwhelming, and I know we were supposed to talk Cloud Practitioner level, but I think that was an interesting last episode for our series to show what is ahead, right, in the cloud journey of someone that is learning Cloud Practitioner level. If you really want to go for that, things can get complex. And the good thing is that by learning good foundations, you can start doing things from the beginning.
Right.
It gets way easier in terms of cloud administration and cloud security.
It can be tempting to jump in the middle, right?
Yes.
But you have to understand the beginning and then build forward from there.
Yeah, and if you go to aws.amazon.com/security, that's the security portal that you can have lots of information, white papers, resources to see where you can learn more. It is the AWS security portal. Compliance frameworks, right? Encryption in transit, encryption at rest, everything security related, you can find in there. AWS partners that can help you with applying security to your account. Well-architected framework. There is a security pillar that it's also listed here. So usually automation is key, right? You would because when things start getting complex with multiple accounts, with multiple roles, with many things, you would like to have automation to prevent human mistakes.
Yeah, you don't want to be manually doing all of these steps repeatedly. It opens the door for human error. So you want to make sure that you're using the correct tooling to reach your end goal instead of doing everything manually in the console.
Yeah, yeah. So the three main pillars of security is the confidentiality, integrity, availability, right? So confidentiality means that the data that is stored, when that data is presented, that data is integral, that data has not been tampered, right? Availability is also something interesting in security, because most attacks, they leverage lack of availability. Like if someone is building a web page for phishing, right? They don't have the systems to run and to respond to the user's request with like their bank balance and things like that. So they will usually capture the password and say, oh, we are offline, I'm sorry. So if your systems are not available, lots of time you end up losing technical credibility among your users. And then like if your solution is offline all the time, someone would not be able to differ a phishing attack or something that is offline on purpose because there is a hacker.
Right, if somebody hijacked it, right,
exactly,
they wouldn't know.
Right? So availability is also something important when you talk about security. And integrity, meaning that if the user who wants to see that data is actually the user who is allowed to see that data, right? So by leveraging these security best practices and these standards, you can ensure that the confidentiality, integrity, and availability are on par with your cloud architecture.
All right, so I think we're coming up at time here. We only have a couple of minutes left. I think we have a ton of questions left here in the chat. I do see one on ABAC, attribute-based
access control.
So you can use IAM for that as well, where you can check for specific attributes of someone's user session, and you can control access based on that as well in your policies. So you can go that route as well. But with our last 2 minutes here, I want to quickly just shout out the AWS Cloud Quest game. Go in, play around. There's lots of learning to be had. It goes deeper even than what we talked about today, especially as you get through the game. So once you get past the first couple of nodes, it's going to get more complex. And you want to make sure that you are learning these good foundations before you try to embark on more complex journeys. And also, if you want to see more of Raf and I, you can find our classes on AWS Skill Builder. You can find them on Coursera and edX, FutureLearn, Udemy. We are on all of these platforms, so please check us out there. there. We're making new classes all the time.
Yeah, we are. So just one last thing about attribute-based access control. In some resources, you can add tags. Like I just added the tag key env and value prod to one specific EC2 instance. Remember when you talked about the conditions you can have in an IAM policy?
Right.
Well, you could create an IAM policy that has a condition that only allow you to interact with that instance if the instance has the key
That
value.
tag.
Yeah. So that's some sort of attribute-based access control, right? So resources that supports tags, you can tag the resources and go on IAM policies, and that would be a good use case for writing your own IAM policy,
Right.
which you can reuse across roles and users and groups, right?
Even if it's customer managed, you can still reuse it. You just get that control.
Exactly.
And this is kind of goes back to that whole idea of convenience versus control.
Yes,
Right? With
yes.
the things that are managed are oftentimes more convenient, but you have less control, where the things that are unmanaged have less convenience, but more control. So remember that as you look at AWS in general, all of these things exist on a spectrum of convenience versus control and generally are built for specific use cases. So we only have 45 seconds left here. So Raf, any final words you would like to say to our audience?
That was a nice journey over these 6 weeks with the Cloud Quest. We dived deeper in security in this episode because we are in AWS Reinforce, a security conference that is happening in the Boston Convention Center. So
Yeah.
I hope you enjoyed our Cloud Quest series. Let us know. I am deployed to prod on Twitter. And let us know. Connect with us on Twitter if you have any question, if you have anything, if you want to learn more, connect with us.
Yep, and I'm Morgan T. Willis on Twitter, so please hit us up. We'd love to interact with you, and thank you so much for joining, and that's it.
That's
All right,
it. Thank
bye.
you.
Thank
Bye-bye.
you.
Thank you.